This is Tui, and we're back with Tui Time Graphics. In this episode, we're going to be going over. I did some code cleanup, and I'll kind of go over those little code cleanup changes, and then we're going to get into lighting. We're going to do ambient lighting in this one. I'll tell you what ambient lighting is in a second. If you don't know what it is, we're going to do ambient, and then in the next one, we're going to do specular and diffuse lighting. So, but for the first part, I just kind of want to go over some of these code cleanup changes I did. I went through and I just kind of got rid of the 2 spaces in the code. I'm getting rid of all these comments, so we don't really need those, to be perfectly honest. Probably could keep them, but I'm not going to. I'm going to keep this stuff here. One of the big things that I want to show you is in shaders. I got rid of the light, and then I got rid of these comments with the light intensity because I don't plan on using them again. We're gonna have dynamic lighting, not just pass in generic lighting. So there's gonna be that, and then this also goes with types. So light doesn't have anything right now. We're gonna fill this up in this episode, and everything else just kind of went through and cleaned up. So I'll do a little. Oh, and I also commented out all of the. So I put, if you look at the folder structure in the node, I moved these around, and then I added the shapes group to put the shapes in, because I actually don't plan on using the shapes again for a little while. If I want to make a cube, I'll make it in the OBJ. I'll make it in like Blender or something like that, so that we have the normals. But since we have the code, I'm still gonna keep it in here. I'm not gonna take it out. So I put the shapes that we made, the generic shapes, into a little folder right here, and then I also created the assets folder up here that has, the models and the images in it, so I can kind of close it down. Let's see what else I did. Yeah, and then in scene, I got rid of the light.set lighting. Oh, and in my main storyboard, I got rid of this thing that we weren't using. There was one that said use lighting. We weren't using it, never actually used it, and it was just causing an error. And so now it should be running a lot better. For my scene, I haven't cleaned this up yet, but what I'm going to do is, so in the future, what I plan on actually doing is we're going to do lighting. I'm going to go over all the lighting aspects. The basic Phong shading, which I'll go over what that is, but we're going to go over Phong shading, and then once we do Phong shading, I want to optimize the system so that it reuses buffers or shows a new buffer, and then while one buffer is loading, it'll show that one, and then I forget the term off the top of my head, and I don't plan on looking it up, but it allows us to use 3 screens at a time rather than just the one and have to do all the work with the one showing. It heightens the CPU, and it reduces our FPS a lot. So we're going to do more optimization in the future episodes. But now that we have this cleanup, let's just let's get rid of this instance, because I don't want the instance. And we're just going to do a basic model in this episode at least. We'll probably do some testing in the next episode. But so we have our model. We're going to add the model. We're not going to move the model's nodes because the models don't have nodes. And then I found that movable object dot position dot y, well, z equals -4. And then I found that we need to move him down because his center, his origin is at his crotch, and that makes him kind of up in the screen. So I'm going to move him down just a hair. Dot y equals -0.5. So now we'll add the movable object, and we should be able to see him very clearly right in the center. I tried using a different screen capture. You've probably heard of OBS, but my computer the CPU just flies, and it does not like me using that. So I've decided that I'm going to stick with this Capto for just a little while longer. If it gives me any more grief, I'll have to deal with it. What I might have to do is stop the video in the middle at like maybe 30 minutes and then just press record again and then concatenate the 2 videos together. Oh, we're getting an error. Look at this. What's going on here? Do you not want to draw for me? What did I do? Oh, okay. So it's not going to run because our light needs like a variable or something. So in light, I'm going to add 2 things that we're going to use today. and then we'll test it out just to make sure it looks good. So we need, for light, we need light color and float 3. Wait, no, float 3, light color. Excuse me, can't just have one. And then a float ambient intensity, and I'll talk about that in a sec. I just want to get this working, make sure that it looks fantastic for testing. And then we had, so make sure these are in the exact same order. If they're not, they're going to go to the GPU and it's going to pick up on the wrong stuff. So the same order as the other, as in on the GPU. So var color, which is going to be a float, equals a float 3, darn it. And then we'll just put that at 1, the light color, and then var ambient intensity, that's going to be a float, and that's going to be just 0.0 for now. Not going to be any ambience. So now let's run it. Yeah, because each one of these structs actually has to have data in it. Equals float 3. In order for it, these structs need to have data so it doesn't freak out and say, there's nothing for me to bind. Why are you making me bind things? There's nothing to bind. There's no size. There's no bytes. So it complains. We could just not apply the binding, but okay. So it looks like we're good. Oh, another thing I did was in the shaders. Okay, yeah, that's running smooth again. So in the shaders, I also in this basic fragment function, instead of doing float for 1, I did vn.color. So I can set the color here to whatever I want, and then I'll come in here. One more thing I want to do for this is go into the model constants, go float. So I want to add, I don't want it to look all rainbowy like that. I want it to give it one just static color over its entire body. So I'm going to just call that, that's going to be a float 4, and I'm going to call it material color, and I'm going to apply that to use that in the model constants, and then I'm going to apply it to all this stuff. So the node, everything can basically have a material color in the game. So we're going to var material color, which is going to be a float 4 equals float 4, and everything will just be white to begin with, and then we'll set it wherever we want. And my types, we need to go to the material model constants and just say var material color equals float 4 1. And now we have that, so let's go ahead and apply that on our scene. So we'll go movable object dot material color equals float 4, and then I'm going to give it gray, so 0.6, and then I'll just copy the 0.6 over and over again because I'm lazy, and then follow it with 1.0. There we go. So now we have a material color. We just need to now apply it. So when we call render on the shape, which would be in primitive, we would just say model constants dot material color equals material color. And we'll want to do that also in the model. Yeah. And well, there's one more place in instances. We also need to do it here, but since we're using the pointer to point at all of them, we'll need to say pointer. We'll use the pointer to, so like, copy that, just paste right under it. Dot material color equals cool. Oh, no dot material color, my bad. So now that we have all of that set up, I should have, and since I passed in gray for the material color, and in our shaders, I haven't even said that yet. So instead of saying vout.color is vin.color, we'll say vout.color equals model constants dot material color. That was too fast. I'm sorry. I'm just trying to add material color so that it makes it smoother. So, because like white and seeing shadows is not nearly as good as, I mean, we will make it white and see shadows, but like I want a gray, a nice dull gray, so that you can really make out the different shapes on a body. So now we have the same exact object, except now we can pass in whatever material color we want for this guy. So that's pretty sweet. So I'm going to stop that. One more thing I want to do this episode before we jump into this ambient intensity lighting is let's pass in the normals. As we're doing light, we will need to get normals. So the way normals work is, oh yeah, I made a diagram, don't worry. So check this out. We have a light position. Let's say this is the sun, okay? We have the sun and it's shining just light in all directions, straight. So the idea, actually theoretically, light does shine out and like a straight ray, theoretically, and there's tons of reading material on Phong shading or light, just shading in general, that is super fascinating. And they go in depth into the physics of light. They don't just say how to do it in computer science. They say this is how light works, and we use these formulas because this is how light works. We're really trying to imitate exactly what light is doing in the real world to create insane, realistic lighting, and it's really fascinating. So I recommend going and checking it out. But what we need to do, so we have our model, okay, and we have our model, our material color, which is purple, and then we have the boundaries. These are the vertices making up the model. Going all the way around, and now for every single vertice, you notice we have a surface norm. Well, we have a normals for every vertice, so every vertex is a normal. But for a whole surface, like so, if I go, let me draw this for you. So if I go like that, so that's our surface. Our surface has a normal. Oh, that was terrible. That was not straight at all. Well, it's got to be nope. Right there. Yep. So like pretend that's straight up. That's perpendicular to this plane. So we have our surface normal. So this is the surface normal. And then we generate this surface normal based off of these normals. So this is a normal, this is a normal, this is a normal, this is a normal, right? And then this is like a triangle. So so really the surface normal would come off of this triangle, and this triangle would also have a surface normal. So we take the normals of this guy and then we give it a surface normal, right? Pretty cool stuff. We're going to get more into that in the next episode. But basically what happens is the normal's facing straight up, right? Or say the light position's here, and this one's kind of the closest position on this model to the light. So it's going to be the brightest. And then you see this one's facing away, and it's in the back. So the light source is here, and it's in the back. So there's not going to be that much light here. It's actually going to be very dark. And so what we can do is we can take this angle that's produced from the angle of from the normal and the vector from the light position. We can take what's known as the dot product right here, this theta, and we can, so this will be from 0 to 1, and we can just multiply this normal, this theta value by that, giving us like lighter, more gradiented lighting, and it's sort of realistic looking. It's kind of basic, but it still looks good. I have another little diagram that I drew that probably will describe it a little bit better, but we have on this sphere, okay, so in order of hardness, okay, hardness and which will apply, because we kind of need all of it to create all of it, right? So, but from the easiest one would be ambient lighting. This is a very simple calculation. What ambient lighting is basically inside your house we have, we have objects around us. So say I were to put a white ball in the center of a room that had nothing but red walls, okay? Actually, let's say white walls. I put a white ball in the middle of the room with all walls are white, right? The ball will stay white because of the light, like the surrounding ambience from the room is white, right? And so if you have like a red light, however, that will change the ambience. The room's walls will be red, and then so the ball is going to be a little bit more red. If you use a blue light, the ambience is going to be more blue, so the ball is going to change a little more blue, and the lights are going to be, or the walls are going to be a little bit more blue. So, you know, there's things reflecting off all sorts of things in your room, and depending on you know, the ambient intensity of that light. So if you have a slightly blue, or, you know, like if you use fluorescent lights or normal lights in your house, they're usually a little yellow. So if you shine that on a white ball, the ball's going to look a little yellow. And so that's what we're going to do first. We're going to apply ambient lighting. Very simple calculation. The next hardest and the next in sequential order that we're going to apply is diffuse lighting. So what diffuse lighting is you have the light source up here, this really happy sun, and he is shining down on this ball, right? And you notice that everything in the back is darker, and everything that is closest to the light will be the brightest part. And it just kind of creates this darker gradient as it goes back. Well, that's what's known as diffuse lighting. It takes in those normals we discussed, and it creates darker all the way back. So this light position uses these normals and creates a darker diffused look along the entire shape of a object. That is like the coolest thing ever. That is how graphics, they calculate lighting that way. Like, that's how they calculate lighting. That's so exciting. How the hell? That's not intuitive. If that's intuitive to you, you're a genius. That is so freaking cool. So basically, that's diffuse lighting. Number 2, hardness. It's just going to need to take in the dot product of the different, the normals and the light source. So it's not the easiest thing to do, but it's still easier than number 3, specular lighting. So specular lighting is going to be a little more complex, because what specular lighting does is, which is this little, all right, in this picture it's this little dot, but realistically if you had another light source right here, there could be another dot right there, and another light source right here, and another dot right there. So that would be like the specular lighting, because if you look at something really glossy, it doesn't just come off as a, you know, it doesn't look matted, it looks glossy, right? It has shiny little points all over the entire object, and that's because what specular lighting does is you put you on the object, you put like a shine, how like the shininess factor of the ball, and if it's really shiny, it's going to have really specular, it's going to shine right back in your face. But if you have something that's like chalk won't really reflect. It'll be bright, but it won't have those little specular dots all over it, right? And so what specular lighting is it generates these, it uses the light source's vertice, right? Or light vertex. So it takes the light source, it takes the reflection angle. So like, so if this is the normal right here, right? And the light's shining at this direction and it comes off in this direction. Well, this is this angle. Let's say it hit there, right? So hit there. There's like this angle right here where it shoots off into space, but like say your eye is right freaking here. Well, you're going to see that specular light. But if you're over here looking at it, you're not really going to see a specular light, because it's going to be a different angle. You know, there's not, the light's not shining right back at your eye. You'll see maybe a specular light over here or something. So that's kind of how that works. That's specular lighting. I'll probably reiterate exactly what we're doing while we're doing it. But yeah, so let's get back to lighting. One thing I'm going to need for the future episode that I just want to apply now is the normals, so that I don't forget about them and wonder, why the hell is my code not working? So we need normals. So let's do some simple normal stuff, okay? So in my model, I'm not going to do shapes or primitives or instances, etc. We need this in model. So our model, in our files, so let's go to our assets, let's go to our model, and let's go to our armadillo, and let's open a source code, maybe? Yeah, so if we go down, oh my god, there's so many. These are pretty big files. Look at that, wait, there was VNs. So here's the VNs. These are the vertex normals, okay? So every vertex will have a normal applied to it. So it'll have, patina, where'd you go? Where'd you go, patina? So, like I said, if we have a triangle, that is not a triangle. And that's not even, So we have a triangle. Let's rotate a little bit. See if I can. So like we have this right here, and it has these normals right here just kind of applied to it. So this is normal, this is normal, this is a normal. Every vertice has a normal attached to it, just like so. So yes, that's all I want to say. So our object files automatically have it on it, so we don't have to worry about that anymore. Okay, going back to the model. When we upload the model, remember this was just uploading all the information off of that file. Well, we didn't actually do the normals. We just did the position, color, and texture coordinates. So we need to add the normals. First thing I'm gonna do though, nope, yep, we're gonna add the normals. So I'm just gonna copy texture coordinates. It's gonna be exactly like this. So let's do the vertex descriptor where we have normals now. So 3, 3, 3, and then okay, so as opposed to doing it this way where we're just doing float 3.size, float 3.size, this is not good because it doesn't really open us up to be able to use other. We're gonna do it a different way. That's all. So instead of memory layout float 3.size, we're just gonna do memory layout of float, and then we're gonna multiply it by 3 because that's what was the previous one. So we're gonna just, since we're using 3 floats here, we may as well just do it this way to make us a little bit. So I'm going to do it on all of these real quick. Remember, don't forget to change the indice in which the attribute is being accessed. So we're going to go 3, and then this is 4 plus 3, which is 7. This is 4 plus 3 plus 2, which is 9. And then those accumulated is going to be 12. You see, like we were using vertex.stride. Well, our vertex doesn't have normal on it in our types, does it? Nope, it doesn't. So if we were using the stride of that, it would be like, oh, it's not big enough. What's our deal? So we're making it big enough by just saying exactly what we're applying to it in the model, at least. Okay, so now we have a vertex descriptor describing them, but let's load them. So let's go to where we're building our model meshes, and let's add another MDL vertex attribute, which would just be normals. Oh my goodness, that's not what I want to do. So we're just going to take this, copy it down. We're going to call this normals. And this will be position 3. Don't forget this. Drive you mad. And we're going to take our normals, copy that, paste it here, paste it here. We'll just call attribute normal. And cool, that's all we need to do for that. That was easy. Very, very, very easy. Okay, very easy. And we're gonna test these normal in a second too. So, now that's done, we need to go into our shader, and we just need to add the texture coordinates. We just need to add the normal. So now we have our normal coming in at attribute 3. Normal. Cool. Cool, huh? So our vertex out will need a normal. So float 3 normal. Normals or float 3s? Did I do that on my model? I just copied it, didn't I? Yep. I put 12, but I knew what it was. It was float 3. Don't worry about it right there. But in here, we need to make sure it's a float 3. So we're going to apply this normal to the vertex out. And so, but first we need to, so V, we'll just do that here. V out dot normal equals, well, so when we rotate the vertices in space, right? So we get them in raw right here, which is around the point 0, 0. But say we rotate our model, now the origins changed a little bit. Like the vertices have changed in world space. And so what we need to do now is just multiply our rotation matrix, our transformations, times the normal position, and that'll move the normal to the current location. So we can just say normal equals model constants dot no I'm gonna create a new, so we're gonna call it var, like how about float 4 by 4, and we're gonna call this world matrix world position equals, it'll be the model constants model view times this, right? So now we take that there, and now we can just multiply this by world position, and then we'll take world position and we'll multiply it by the v in dot normal, right? So now we have a normal in world position. Let me see here. So now in our fragment function we have a v in coming in. So in order to test this, actually I'm just going to run it, make sure it builds. But in order to test this, what we can do is, since we have a value for every single one of our oh no, world position, model constant, model view matrix. What are you doing? You're float by 4 times the v in that position, which is a vector 4. Vec float 4, vector of float 4 values to. Because it returns a float 4, not a. Okay, all right. The normal will be a float 3, so this needs to be a float 4. Okay, I think everybody is going to be happy now. Go. Oh, and then I guess I got to give it a homogeneous coordinate. Oh, God. World position is a float 4 times. Oh, the norm. Oh, right. I think I'm doing this right. I hope I'm doing this right. Let me see. I have some notes here. Make sure I'm. Yeah. Yeah, I took notes just to. I tried this out. I didn't want to look silly. Oh, right. Yeah, so. Surface normal. Yeah, sorry. So we're not going to call the V-outs thing just a normal. It'll be the surface normal because it will be the transformed normal. So we're going to call it the surface normal. V-out.surface normal equals, well, we don't need float. We can remove this, but we will need the normal that comes in to be a float 4 normal, because world position is a float 4. We're going to convert this here, but since our surface normal is only float 3, we need to just take the dot xyz, xyz from this, apply it, run it, make sure that it likes that. So yeah, basically this is the surface normal. We don't want to just call it the normal because the vertex has the normal, right? We want to make sure that it calls itself. Oh, and I'm also, I didn't do this. Let's change the background. This gray is a little funky. I'm going to use a preset color that I made. You can use whatever color you want, but I'm going to use this. You want to know what color that actually is. It's these values. So you can click right here, and then you have 35, 155, 144. And I just like this color. I mean, yeah, I like that color. How about 35, 174, 141? All right, that's what my color is. Just in case you want to know. Let's go back to the shaders. Let's run it again with that background. So yeah, nothing's breaking. We're taking in these normals. It's passing them in just fine. But let's test these normals. So every single vertex surface normal has a number applied to it, right? And so what we can do is we can say in the fragment shader, set my color to the float 3. Well, we'll use the float 3 to the color, the float 3 values that are being passed in from the normals. So watch this. So since these normals, so we can say color equals, let's not say that. Let's say float 4 will go vin dot surface normal 1. Now, I mean, pseudo lighting, but not really. This should work, and we should have these really cool. Ooh, okay. Yeah. See? So like based on the normal it currently has, it's going to change color. And you'll notice that the color isn't changing as we rotate him through the world. But as he, if we, okay, so we're gonna move the camera. We move the camera, the normals change, right? Based on the eye, the origin, 0, 0, moving the camera change. But when we move him, his colors aren't changing. See that? No, they're kind of changing. But yeah, so you can see all the definition in them based on his surface normals. I'm gonna make sure that this is all correct real quick. Just running through. Let's not use, so in my previous example when I did this I used 0, so I'll try 0 right here and just see if anything's different. I'm pretty sure it won't be. One other thing we didn't do is so it's using these values. Oh man, that's so freaking cool looking though. So we need to actually do something called normalization. So you really should brush up on your matrix math. But what normalization is it takes the direction of a vector and say that like the direction and magnitude is like 400. Well, it takes that and just shrinks it down to a unit, which is one vector. So the vector becomes 1 from wherever the magnitude is. It just shrinks it down to 1, and then it uses that 1 because it doesn't need to be 40. It only needs to be 1 to get that angle, because that's all it needs. So yeah, let's do that. Let's go normalize vn.surface normal, and boom. Let's run that and see if anything happens differently. I have it a little different the way I laid it out before, but let's see if this gives us any different values. And no. Nope. Nope. What else? I remember it looking a little different, so I'm kind of curious as to what's going on. So it must be. Let me see. Yeah, no, that looks good. So I'm gonna use this right here, and I'm just gonna call it the unit normal. So float 3 unit normal equals normalize the vn.surface normal call it unit normal, and that should be good. But I don't want to do that anymore. I want to just do vn.color. Because we need to move on to ambient lighting. What are we at? Yeah, it's going to be a pretty short one. So let's move on to ambient lighting. So, like I said, when we do ambient lighting, we need just 2 simple values, right? We've already put them in the types. But we need the color of the light that's shining in the room and the intensity at which it's shining on our object. If you have a if you have a white ball in the center of a room with white walls and you have a light that's just sort of blue, the light's gonna have a sort of blue. But if the ambient intensity is blue, the ball's gonna it's just gonna be blue all over the place. And so let's just apply that. And then how all these work is when we have the specular, the ambient, and the diffuse, well, we make the ambient, and then we add on top of it, literally add the plus, the diffuse, and then we add specular lighting, and they add together to create this final colored model. So let's do that. So we have color and ambient intensity, right? So it's very simple. It's insanely simple. All we need to do is in our basic, so we don't need the unit normal right now. We just need the vn.color, which is our model's color, and then we also need the light color. So I'm gonna just call this what do I call it here? Ambient color, I guess. Float 3 yeah, float 3 ambient color equals light dot color and plus or times light dot intensity. Ambient intensity. So that's going to give us our ambient color. So we have those two things coming in, just making sure. And then now I can say, just right here, color equals color times ambient color. But this will have to be a float 4. So let's say and boom. So now let's press play. The ambient intensity is kind of low, so let's go to our types right here. Let's make it 0.5, and we're gonna make it the color. No, you know what? Let's do it here. I'm a silly duck. We can do it right here. So our scene has a light attached to it, right? So if I go light dot ambient intensity equals 0.5, and I go light dot color equals float 3, and then I'll give it a red. Oh, I've been saying blue all day, so I'll give it blue value right there. Now if we press play, our object should have a very, well, not all the way red, but fairly red, just kind of color to them. Tint. And blue, I meant. Oh, green. Okay, so apparently it's green. I don't know my RGB values at all. Let's do one right there, 0.5. So let's make a preference for this and a slider. So I'm gonna go to my main storyboard. I'm just gonna add a little slider real quick. So UI or NS slider, horizontal slider right there, and then just a label to attach to it. And this will be for our models, just for testing. This will be ambient intensity. So I'll just put that right there. We're gonna take this model down here, model control. Do that, probably stretch this out a little bit just to fill there. And let's click on the view controller, open up here, should bring up the view. Yep. And now we can just drag this guy on there to go right here. No, I'm gonna make it just an action because we have sender. Gonna call this slider ambient intensity changed. I'm gonna go connection outlet action, connect it. It's gonna take in a sender, which is an any, but I don't want an any, I want an NS slider. And then I can say preferences dot ambient intensity. So we got to go to our preferences. Just add a quick. I'm gonna copy this. I'm gonna go right there. I'm gonna call it ambient intensity. And then I'm gonna make it not metal clear color. That's for sure. And I will say float equals 0.0, so there. And then I'll just make it a set, just like I did here. Set ambient intensity to ambient intensity. Taking the color, this will be a float. And then we'll just go ambient. Oop. Gee whiz. Ambient intensity equals ambient intensity. But I'll call self dot just to do that. And I'll even do on my clear color self dot. So there we go. That's that. Let's go to our we render. It's going to be our scene.render, and we will just need our basic scene, I guess. We're updating the input since we're just doing this all the time. I'll just do it in here just for now. This is input, update input. This is literally update input. I feel bad putting it in here. I'm gonna put it in the scene render. I'll just put light.ambient intensity equals preferences dot ambient intensity. And so it'll update all the time based off what we select. Our main storyboard one more time. Click on this. Over here you'll see we need to click continuous, or else it's only when we drop it. And yeah, let's press play. See what happens. Oh, I should have set the... Oh, no. Press stop. Stop. All right, so we need to click our slider. It needs to be from 0 to 100. Current is going to be at 50. It'll be at 0. And then what I also want to do is obviously do the slider change. So preferences dot set ambient intensity to you can just say sender dot float value. Cool. That's at 0. Everything's at 0. Boom. Fun stuff. Okay, let's check time. Should be ending like pretty quick. Hopefully, if ambient intensity works. So we want our ambient intensity to be blue. Oh, no, that's wrong. So it's gonna just watch this. No, that's wrong. So we need to say divided by 100 because it's a float value between 0 and 1, like I said. So let's pass in 0, 2, there. I mean, I could just add 100 ticks, but why would I do that, right? It's pointless. And then I'll probably group these together before. So we have that initialization successful. We're at 0, 0. Let's do ambient intensity as we go up. You see, like very subtle light blue light coming from the room. Let's change the background to white. Let's do the clear color to like this white, so you can really see. So we're in a white room with white walls, but we have a blue light coming, right? Like there's no walls obviously, but there's a blue light shining, and so the dark areas are going to be a little blue, but where there's specular lighting it'll diffuse to the blue in the background. And so yeah, basically that is what's up. That is ambient lighting. Yes, what did I say I was going to do? I was going to do something. Can't remember. That was a pretty simple episode, to tell you the truth. We only did some code cleanup and just explanation of lighting. I'm going to do more explaining of lighting in the next episode. There's got to be something else that I haven't gone over. What was I going to do? We're not using this surface normal yet, so we can just kind of comment it out, I guess. We will use you in the next episode. Yeah, let's so let's go to our basic scene. Material color, ambient intensity is 0.5. It's just, we don't even need that anymore. It's just kind of based off our stuff. The light dot color. I mean, we could even add that as another control just to really change the different lighting colors of the room. No, that's okay. We don't need to change. Actually, let's change. Yeah, you saw. Okay. Yep. So that's good. That's good. I'm gonna, just for the next episode, I want to kind of just do this, uncomment the this, so that, because I want to kind of end it with like a shiny, like of something that we did from here on out. So I'm gonna end on this note. Oh, one more thing we could test. Let's test one more thing. Sorry. So see, we can just, oh man, it's so cool how dynamic it is and how fast it works. But let's pass in an image name and see if it works for our, like, so if we give them a stone.png, and then I need to go into my shaders and just kind of copy exactly what I did here. Ambient color, and then color equals color times there. So I'll go there, and we'll just go to our textured, do the same exact thing, and press play and see what happens. We should get the exact same. It should sample the texture color and then take the ambient color applied to it. And yeah, let's see. Let's hope it works. Okay, so we give it, see, so that's obviously a really crappy texture to apply to it, but if you look closely, you see we have our texture and it's still getting that ambience applied. So that's good. It's good. It's working exactly how we want it to. And since the texture is very gray, it's like really dark gray, it's only going to be a little bit like that. So you can see how detail can really start to take form in this. So I'll leave it with that. Yes, and I thought of a new tagline to say at the end of my show that I'm kind of excited about. So I'll just say it right now. Ready? All right, guys. Thanks for watching, and goodbye, cruel world. That's a little dramatic, but goodbye, cruel world.